Right, welcome back. So I've tidied stuff up a little bit here. It's still the same. I've just got the simple versions here. So the next thing I'm going to do is I'm going to look at a way of emitting different versions of the USD geometry variant and getting the proxy and everything back out in the viewport. Just another way of doing it with a more streamlined workflow. So what we're going to have in the viewport is we're going to have a very cheap simulation where they emit every so many frames, then it's going to fly in, and you'll notice the rest blend's still working, and that's it. They just spin around. So it's a really basic sim just to kind of get where we need to be. But once we get this in place, we'll kind of crank, well, you guys can crank this up and have a play with all sorts, I guess. So nothing's changed here. In terms of the top level of the SOP modify, it's still the same. So I'm going to go through it from the top. So it's going to look a little different. So as you know, we bring in the geometry here. Let's just make sure we're hiding anything else. Looks like they've added some new features in here as well. That's interesting. So we bring in the model, and I'm just going to make sure it's at the rest, and then I do a poly reduce on the fascia and on the skin. Not much really, just for the hell of it, so you can kind of see we've got what we need. And then, as you've seen before, I basically create tetrahedral meshes, vellum constraints in here like so, and they're all kind of neatly named. Now we could loop this and just have one system loop through a list of names or something, but I like to give because they're all different shapes in these groups, even though these groups are procedural, I just chose to do it separately, just for what I need. Again, it's down to you guys, you know, to get what you need. But what we'll end up with is all of this simulation data here. We're going to have as you've seen before, we're going to have the groups. It's going to define which this is going to have a group named after the geometry, and it's going to have the interior and the surface, and it's going to have the surface triangles, but they're named clearly. So when we merge these together in a merge SOP here, we can kind of take a look at each one. You could also put a star in there and it'll bring them all in. If you're very good with your naming conventions and this kind of doesn't pull in anything else, it's up to you, but I like to just do it like this sometimes. It's not too painful, but if you've got like a lot of these, then this is where wildcards and looping comes into play. You can get a lot done in a very small network, which is wrapped in a for each loop with metadata kind of driving certain iterations, I guess. So you end up with the sim geometry here, and then the render geometry is the stuff that we've been splitting out. So we took the original USD, and as you remember, we've basically extracted just the render geometry, which is the thick skin, which is the skin color here, and the slightly lighter purple, and then the other piece of geometry, the fascia in the middle. So we have little bits to this creature, and then we've got the proxy that we created for the viewport, and this does actually contain all the insides as well, which may be a bit overkill, but we left it in when we originally built this asset. So we do that, and we essentially get all the proxies, and then we do the same, we get all the render. So I just merged those together. Again, I could have used one merge node if I wanted, but it's just easy to kind of keep the data in flow. And then I'm going to take, what I'm going to do here is I'm going to create a geo ID, and all I'm doing is I'm taking the path here like so, and I'm slicing off 4, so I'm getting 1 2 3 4, so I'm landing on this string here, and that's basically going to let me create this geo ID. So I'm just grabbing the name here of the actual, well, I guess the asset, and then for the sim geometry, I created a name when I packed it, $OS. So I just happened to call this the name that I'm deriving here as well. And then I created another geo ID off of that name. So these also have a geo ID, which is point. and these have a geo ID with point. So when they're merged together, they all belong in the same point attribute. So all of this proxy, render, and sim geometry, they have this geometry ID, which is quite handy. So then we'll set up like emission. So again, up here, we've got just a generic kind of scattering and trying to create some points on the surface with some random velocities on these points. So if you can see those points. And then we're going to create a asset ID, I'm calling this. So this is the number here. So it's just going to basically give me a unique asset ID for each point. And then I'm going to bring in the geometry, and I'm going to take that geo ID and I'm going to enumerate this into a variant attribute. I'm going to call it variant. It's going to be an integer. It's going to create the variant. So you can see that like C is 2, and as you can see, whenever we find a C, it'll be 2, and it's like an ID variant. Oops. So then I'm just going to basically say that this point, it comes a primitive attribute, like an attribute here. I'm going to rotate this for a correct instancing, maybe not that essential at this point. Then we're going to do an attribute from pieces using the variant. And then we're just going to clean up any other bits and bobs we didn't use. And then I've got a temporary cull here. So we do actually have a lot more points going off in here. But when we copy this now, if we copy this, you get, for each copy, you get like the simulation geometry put in place. You get the original render geometry and the proxy geometry. So the render purpose and the proxy purpose and the sim mesh all sit together, and that changes over time like that, all getting this unique geo ID and asset ID like so. So if I don't call this, you can see it kind of still works. So, but I'm just calling this so I don't change the system. You might kind of get the right amount and then just want to test it, and you can just call using these wrangle nodes with a bit of vex. And then what I'm doing is I'm putting this into an expression which is just going to make this appear like boom. Like it's probably going to be about 2 times because of the amount of time this switches off at this frame here, 1000, and it emits every 28 frames. So it's going to kind of go boop, boop, and then it's finished. So I'm just going to get 2 emissions of that amount there, and each emission will be slightly different rotation, a different position. So that's that. And then once we've done with that, I can kind of extract back the sim geometry to go into Vellum. So that's, remember, that's packed simulation geometry. So if we land on a frame that it's actually can I grab that frame? You can see that that will be packed geometry, and we can tell by looking at the names. You kind of got this going off in here as well. So we've got like Vellum type, and you can see that this is the packed geometry. So each one of those has a so monster. There's 2 monster A's, loc 1, 2, and 2, and they're the red ones, and they've both got geometry and constraint packed. Then we have the original. On this side, we have extracted the render geometry and the proxy geometry to use later on. So these are output nodes set to 0, 1, and 2. We press U, we're sending out these signals. So it's the same thing here. So they can be used later on. And you can see this little brown line here is just it's just a representation of like there's a connection there. So you can view that by having this on. So when you select it, you can see where I'm using that expression. So I'm going to unpack, and I'm going to bring back the name and the asset ID as well. And then I'm just going to add some random density and friction, and then plug the constraints and the Vellum geo into the solver. So that's that. So inside of the solver, as you remember, we have the Vellum emit. So this is emitting each frame like so. This is all done. You can ignore that, it's not being used. So this is emitting just constantly each frame from this, which is basically referencing up here the geometry and the constraints. So we'll essentially get Vellum emitting in. Now, my emission is a bit rubbish. I could go to town on how you emit things without intersecting on emission and stuff, but it's not the point of the tutorial. It's just about getting some multiple assets simulated, and we're just choosing Vellum in this case. So they're emitting and they're spinning because on my points I've got like the points are animated and they've got a velocity and a W attribute and a V attribute. So they're just inheriting that initial spin, and then they're being pulled in with the pop attract and things like that, and with groups kind of biasing where the points are being attracted to. So you just get something like a ball of monsters, something interesting. I'm not really art directing the simulation. My tests that I've been doing were just like testing different workflows and then cranking it up to see how far I could push it before my machine totally crashed. Yeah, so it's fairly, you know, the sim resolution is fairly mid-range. I think it's mid-range, what I'm used to using. Yeah, it's not too bad. So yeah, they're going to emit in like so. We'll just might as well let this finish simulating so you can see roughly. So my solver's like substeps is on 4 and constraints is 100, and I've got post collision passes on 8. Might be a bit much that for this test. And again, we're starting at this 950 frame here, so off they go. Now you may notice that they are still pulsating as well, because the rest blend inside is activated here. So if you remember, it's accessing these constraints and it's pointing to click this, it's pointing over here. In fact, there's a hint here, it's pointing to this system. So in order to get this to work, I realize now, because I'm emitting, unlike before, I had to put my points into a SOP solver to accumulate the points over time. So these are all the points that are actually getting emitted. And this will be the geometry as it's being emitted as well. So that's pretty much that. So, and the SOP solver, all I'm doing is just plugging in the to the previous frame and just doing this. So it's basically just going to add to the previous frame. So then I can copy some balls on. Now this might be a bit overkill, this bit here, like so, but I created an attribute on these points called grow. And you can see it's that 0 to 1. I don't want to go too far into this, but it's just ranging from 0 to 1. So it's kind of like a blend shape on and off type of thing I wanted. And then I just did an attribute transfer, and I transferred, you know, some of those like points. Now I did realize that this really should have been like on each frame, but I'm just going to go with it for now. If you know what I mean. If you look at these are actually being fed into the system correct as it's been emitted 1, 2 kind of thing, whereas this is like just accumulating all my points, which I can fix that, but I can't be bothered. For now, it's just going to basically create a grow attribute on the geometry. So you're going to get this like kind of weird blend patch, which is quite interesting. And I'll blur that off. Then again, I put that through the loop, as you've seen before, and you end up with like just like pulsating nonsense, like going like this, and that's what's driving the rest blend. So not really essential. You could do a lot of this without any of the stuff on the left and this, so you don't need any of that. Then I do a cleanup again, so we've got the simulation coming in with just the bits we need. So we've just got velocity, and then I clean up any groups as well. So I'm just kind of saving to disk only what I need. So again, it's when we actually have some geometry to analyze. But as you can see, we've got the asset ID, the rest, the color, optional really. And yeah, just these. The path isn't, I don't think it's useful, but I just kept it in case I needed it for something. And then we've got nicely named groups, which we did back up in here that I've explained inside of here later on as well. That's an unlocked asset. So when you get the file, it'll just be, the nodes will be there. So you don't have to worry about that. And then because this has still got internal text, you just do a convert text that removes it, just add a normal, and then you can cache that out. Let's just cache it out to disk. So now you've got a cached simulation ready to go. But now we need to send that back to the lighting team, don't we? We need to send this back out into Solaris. So what I've done here is I've grabbed the out render purpose here, like so. Now you won't see anything because it's been added each frame. If you remember, it's kind of like adding in each frame like that. And I've got the rest position as well, and that matches, and that's on and off. And then I've used the SOP solver again with the same scenario in here and in here to add the previous frame in. So what it'll do, as this thing is like emitting geometry into the scene, this will kind of replicate that for the geometry to deform. So it will say this deforms and then that deforms. And then it needs a rest position for the simulation. Whoops. So the rest geometry will be the same. So it needs to be like roughly the same time this emits, the same frame. It needs to be in the same position as the render geometry, like it is. And this needs to be the same point count as this. So, and that is, so it's kind of like, exactly the same, look, in terms of 12,500. So that's going to point deform those, and I'm going to use that asset ID to kind of identify all the points that need to be deformed individually. So this is going to take the asset ID and like partition the deformation off. So what we'll end up with now is the simulation geometry coming in like this, and it's going to point deform both the render and the proxy purpose. So you can see I've done that by just grabbing this here and plugging that in to here, and grabbing this here and plugging that into one object merge as well. So it's just grabbed them both and it's point deformed them both, and that might be enough for me for this. Then we've got some retiming, but we'll talk about that in a second. Then the next thing to do is to split out on the left the render geometry, and we want to bring in the velocity and apply the velocity onto those points so we get motion blur. And then what we do on the left, we do on the right. So we do a promote attribute. So we're going to get to this asset ID here, and we're going to use this, and I'm just going to basically add it to the path. And I thought that would just be enough for me. It just gives a unique piece of geometry for each one. I think that might be okay. And we do the same for the proxy. So next then, I decided to optimize my viewport proxy from the original one, which had the inside, and just blast out the inside group that we had on the model when we built it and the fascia. And then we're going to set this into the right space for USD. Then we're going to add the frame sample stuff we discussed earlier. And then we're going to make sure that this is not invisible, because when it came in, it was tagged with, these original geometries were tagged with an attribute which was USD visibility, which is caused from, I think it might be the prune SOP that hides things. I think it adds this. So you can actually set an attribute to make it visible again. So then we can bake this out, and we should be good. We should be able to, when this is done, surface back up into Solaris world and see this, and then we can put that into the geometry clip sequence setup and convert that to USD. and then assign some materials, and we should hopefully be back up and running. So we're almost done. All right. So what we can do is take a look. What we can do is take a look here. And again, I'm just splitting out, basically using my Solaris stuff here. And we've got the proxy for the viewport as well. So, and this is what's being sent out. So it's everything now. It's the render proxy, the render purpose, and the proxy purpose. So press U, this is what we get. So straight away the viewport is updated and we get this. So we don't have a camera that's in the right place or anything like that, but don't worry about that. And it's kind of quick. We've got no materials on it or anything like that, but this could get quite heavy if we have a lot of geometry like we have in the past. So what I'm going to do is I'm going to set this to manual. I'm going to copy all of this just while we're testing and dump that here. And I'm going to plug that into there, get rid of that guy, it's not used, like that. And then on the geometry clip sequence, I'm going to just link the output of this guy into 3, like so, and make sure the fetch source is kind of going back up to the source, which is the original here, like so. And that should be just pretty much good to go, I think. Yeah, it's all unique. It's got a unique name here, so that's all good. So I'll just put my mouse display flag here, and let's just check the frame range. That's probably okay. I just want to check that we do actually have the a right amount of sim stuff in there. Oh, that's okay. And then back on this guy, this is in fact correct and starting at the right place. And I think that's all linked up as well. So I'm just going to set that to auto update. And I'm going to force that to disk. And it's going to force all this data in this geometry clip sequence to disk. So the system is in place for us to kind of iterate the amount and stuff now as well. And I kind of, maybe I'm doing this wrong. It feels painful. The whole thing feels very painful, but maybe there's a better way of doing it. Who knows? But then what we'll end up with is another set of data, this time USD, in the structure, in the tree structure, and then we can just apply shaders and cameras and start rendering this as well. So it's not too painful because we don't have much geometry at the moment. But again, as soon as you add more geometry, you've got longer sim times, then you've got longer bake times, then you've got this longer USD baking stage as well. And then the last part here, when it's gone through to the very last frame, it kind of hangs for a little bit. Does some USD magic. It's probably just filling all those references in and all that data is getting completed on disk. I've waited. Some of those big animations I did, this took like an hour and a half, this process, on top of the stuff within here. So like my huge simulation that I did, that swarmy thing, I didn't have I had the same Vellum settings that you see there, and it took, for those 350 frames or whatever, it took, the Vellum sim took about an hour, which is pretty cool, and the baking took about half an hour. Let's see what we've done wrong here. So I think now we have to take that off, because I think it'll have a problem because they're not actually matching scene graph structure, are they? And I think this is where it can get a bit confusing and slow. Okay. So yeah, you can see it's pretty fast now. I did forget, because we're like, it's almost like how a fluid sim would work, right? You'd be emitting or reseeding and adding to the system. So we're looking at the proxy. So we just want to, I want to bake that down, see what happens. Now this comes back in. So this is the proxy geometry. So it's quite quick, isn't it? So, and as you remember, or if you remember when I don't know if this still actually exists, but we did the same thing here with this, but we have different, where we're not emitting, they already exist. If you remember, they already exist on Space G. They all exist at the same time, so there's no emission going off there. They're just being like spun and dropped. And we did it in many different ways to finalize it with this kind of way here. So like so. And then let's just, because I'm sandboxing, I'm going to just plug this in here and just make this work for this particular test. You can ignore that note. I don't think, I think I figured out what that's all about. I'll talk about that in a second. So that should assign the materials on, and then I can randomize. Let's just hope that this all works again. I think it's going to work. We can set a render range, and then I will just use this node to render. Let's just see where my camera looks at for now. So just frame that up, something rubbish like that. There we go. We might as well try and render this and see what we get. So yeah, they're emitting. So you would obviously emit off screen and do some interesting stuff here. Let's just render one frame. So what I've got in here is I've got like two ROPs. I've got this one, and this one is pretty much a reference copy. So this is responsible for my beauty pass. So what that means is if I render this current frame, render to mplay, it's going to render a bunch of settings that I've got in here, and a path it's going to go to a certain path for me. Like so, I've got a version control there. It's coming from the context option. I've just got like shortened version I sometimes fill in. Again, that's all going to change pretty soon. We'll put that to aces, and these AOVs, I basically have them here like that, and I just throw up, these are what will kind of create the beauty, apart from the ambient occlusion, but these are all the things that I'd like to denoise as well. So the AOVs coming through are all going to be denoised, and I've got a lot of AOVs. I split all the lights out, and I split all the shadows out, so it does make the file size for the EXR a little bit larger, but it just gives you ultimate flexibility in comp if you want to go into a comp with it and things. And then on this side, I call the lights and I add a crypto mats, just using primitive and materials in this case. And then I'm just pulling in some utilities, doing the texture coordinates, the normal, the albedo, things that do not need to be and shouldn't be denoised. And I'll render that separately. So that's usually really quick render. But before I can comp, I need them both done. So I usually have a little top net graph here, which just runs both of those ROPs. So it just pulls both of those in and renders them out like so. So yeah, so there's the kind of weird creaturey things just coming through now with all the AOVs. So got ambient occlusion, it's been denoised, got unshadowed, shadow. There's so many things you can do in here. It's not really going to be a tutorial about that, but my comps are going to use some of these up quite well. So yeah, so the renders usually take 2 to 3 minutes, even for those huge scenes, I didn't use a large resolution. I'll talk about that in another tutorial if you like, but I'm only rendering this resolution. And for samples, I've only done 512, so I don't want to wait forever, and it's just enough for a test. And then in Nuke, I push that up to HD when I've done the comp. There's a bit of a nice upscaling trick you can do in Nuke, and then you can upscale it as well. You can super enhance it in DaVinci Resolve on export as well, after you've done all your grading and your editing and things. So yeah, so this will be pretty much the end of the tutorial. It's not about rendering, but if you want to see the comps and the DaVinci Resolve workflow, just subscribe, like it, get me a comment on there, and I will make that video if you like, and I'll even send the scenes to Patreon as well if you're interested in it, because I'm no expert in comp or Nuke in DaVinci Resolve, but I get by. So yeah, so there is the one frame, which took like 3 minutes. Strange, it takes the same amount of time as the full frame, which is interesting. So, but yeah, so we could just render one more, take a look. So, oh, and the lights, I've literally just got an environment light and a key light, so I'm not really doing anything fancy with it. For me, it was more about the workflow of getting in this, you know, this a bunch of guys here. You remember our little lineup, just wait for this to wake up. So these USD assets we built in a previous tutorial and doing some stuff with them. So it's going to just load in the proxy geometry and do a kind of a temporary preview for the texture as well on all of these, like that. So that's the kind of the lineup, and we chose to simulate just 3 of those, didn't we? We kind of put them into an asset collection here and then sent them into Houdini world in here, and we output basically this, and really quick as well. So it's kind of, I don't know if it's the correct way of doing things, but it's kind of returning the images I need for now. So if you've got any other suggestions, let me know. I'm still reading up heavily on this guy, but it is very handy in some ways for for getting quick previews out. It's going to help with lighting and layout and stuff as well, and just generic. That's just going to help really, than having a sluggish viewport. Yeah, so again, that one's kind of popped out as well in just nearly 2 minutes. So, and that's because there's less motion blur and everything. So yeah. So yeah, I'll put this file on Patreon. Just one thing, I made a note down here. Sometimes when my RAM is full or my GPU is full, Houdini just starts rendering with CPU, and I notice my denoiser stopped working on my images. And I think that's what had happened. So a 2 to 3 minute render per frame, as you saw, suddenly turned 10 to 15 minutes. And that magically happened one night. I set this off at 6 o'clock and it kind of gave up at 8 o'clock in the evening, and it was just rendering 10 to 15 minutes. I came in and there was only like 10 frames done or something, or it was pretty painful. And then there were no denoising in there as well. But I think that was just my system RAM failing. So I probably pushed my machine too far. And that's the only time I've seen that weirdness happen there. So yeah. So just in case you experienced that, I'll just mention it there. So yeah, so there is our quick, like, weird Instagram piece. I don't know what it is, to be honest. But hopefully there's some takeaways from my ramblings within this bunch of tutorials. And yeah, take care. I'll see you all in the next one. Thanks for watching. If you're finding this tutorial useful, why not drop a like and let me know in the comments. And if you're interested in learning more Houdini, hit that subscribe button so you don't miss out on the next tutorial.